The diagram shows a body of mass 65 kilograms attached to the end B of a uniform rigid rod AB of length 4 meters. The mass of the rod is 35 kilograms. The rod is held horizontally in equilibrium by two smooth cylindrical pegs, one at A and another at C, where AC is equal to 1.2 meters. Write down the moment of the weight of the rod about the point A, state your units clearly, and find the forces exerted on the rod at A and C. So I've got the question in summary form here with all the numbers put in. So the mass of the rod, 4 meters long, is 35 kilograms, so its weight here, will be 35 G, won't it, acting through the center of gravity. 35 G acts down there. The moment of the weight of the rod about A, so the weight of the rod is 35 G about A. This distance here is 2. So answer then will be the force times the distance, 35 G, times its perpendicular distance from A, which is 2. So that's equal to 70 G. The units are Newton meters, aren't they? Okay, so that's good. So part B now. Find the forces exerted on the rod at A and C. Okay, so we've got the moment due to the weight. There's a reaction here. We'll call it RC. And there's going to be a reaction here of RA. So, moments around A then. Let's take moment around A. So, we know that RC times 1.2 is a plus there, is minus this one, 35G times 2, which is 70G, minus the weight here, which is 65G, times its distance, which is 4. And that moment must equal 0. So RC then is equal to, move these two things over, 70G plus 265 is 130, and double that again is 260. 465 is 260. G over the 1.2. 260 and 70 is 330 G over 1.2. So that tells us then what RC is, the reaction at C. Tap it in the calculator then, 330 G times the 9.8 divided by 1.2 equals 2695. And that would be newtons, that force there. And now we can use F equals ma vertically. So RC is equal to these three weights, these three forces rather, isn't it? So applying F equals ma in the vertical direction gives, so what was it then? Let's have a look at the picture. It's RC is equal to these three forces, isn't it, because they balance out. So 2695 is RC is equal to RA, because that acts downwards, plus the 65G, the weight of the weight, and plus 35G. It's the weight of the rod. So that tells us then RA is equal to, well, it's 2695 minus 100G, which is 2695. 100 times 9.8 is 980. So take away 1000 and add 20. So it's 1695, add 20, 1715 newtons. Tap it in the calculator if you need to. Let's just double check it anyway. 2695 minus 980, 1715 newtons. So that's the reaction force. So let's just check we've answered the question. Find the forces exerted on the rod at A and C, which we've done, these two forces.